Hello. So, first thing I would like to introduce myself. My name is Martin Krug from Slovakia. Well, I decided practically to share my experience with new technology, and I decided to step up here and show you my experience with new AC products from a MikroTik. Good. So, first thing when I came to these new technologies and they came up on the market, I waited in queue to get them first or as quick as I could. Usually the problem is that when the new technology arrives on the market, everybody starts or waits for everybody else to implement the new technology and try it and make some tests, see performance, the noise level and everything around it. Even we had few talks yesterday about this technology, and guys told me that, okay, we had it on the desk, we test some equipment, and right now it is sitting in the drawers because we didn't get the output of it what we wanted. And that's exactly what's happening when a new technology arrives. So the question is, will it work in a high interference in our cities through the Europe? I think there is really lots of links which they are outside, and they cause really high noise. And second question will be really replacing the stuff will be effort, the work, will be effort, the money that we put into it. So it costs, for example, there is a cost for antennas, the costs of the replacing stuff, and cost of technician work, technician time as well. So we wait usually till somebody will come up with experience. And if they go, we will try slowly to implement stuff. So I did it for you. I took some equipment and I really just hit it with everything what I could, not with hammers, but I adjusted antennas so I can install the stuff upside. In some cases, I took some angled grounder to get some a little bit more space on holder, so I can install the router on it. I didn't damage the router, but I just got a little bit from the cover, so I can get cables through. So it was really hard test for the devices, and I put it in directly into the outside. So I have a few screens later, which are showing you directly where it is. But what I did test it. Well, first thing I did have their older devices. Well, they were not really old. It was 811N technology, so it was like 1-2 years old. But I did want to have better performance, so I replaced some links which I did had before with RB911G. There was the point-to-point links, and I had one old Ubiquiti installation for point-to-multipoint. So I did replace them, and here is the testing practically procedure. So I did placed on both sides CCR routers that I can practically put some traffic test on the link. So the traffic will, usually if you do the tests on the desk and you are using router to router, or access point to client test, it will just overload your CPUs, and the test will not be trustful. So I just installed the two CCRs on both ends to test the link. So we can compare the link, what was there before and after replacing. So the first point-to-point link that I did had, and I did replaced, it was for practically 8 kilometers long. And it is in high noise. It was from city to city, and even on another sides, I did had another links as well. As you can see, on the left side down, there is another 3 links with older technology. So I can really see if the new link will affect the older technology as well. So that was the first link that I did replaced, and here it is the second link. It was quite shorter, and there was on the right side down you can see the multi-point installation. It is map from my city. It's Zvolen and Žiarna Dronom, where I'm acting as an ISP. So it is in real traffic, and it is used for people that are using the links for internet access. Okay, so my testing procedure was based on comparing the old technology and new technology in the same area with the same antennas, practically with the same customers. First thing I did some frequency scans, so I can see how it looks around, and I done even some spectral scanning. I don't have all screens here on the presentation because I have only from MikroTik Dude some print screens, but well, at least something. And well, as you can see, there is lots of interference. It's not just like few access points. I counted 74 APs outside. It's quite a lot, and I think it's, well, you can see that the signal-to-noise ratio, it started at 71 dB. That was the closest link that was maybe on the same side. That was on the same side. Another access connection that I did have on the same side. And there is some concurrence link as well, and well, the signal-to-noise ratio, it's about 36 dB in average value, so it's quite a high noise in that installation. So this is the map where practically I did a map of concurrent links. And the size of the star mean the number of access points that are installed. So there are some buildings, and I did just compare. I was just looking at the different sites, looking for numbers of antennas, looking for number of links that are in my area. So even you can see that through main link. There was one big provider which was just sitting directly on middle of the connection, of the tested connection. That is the biggest star in the middle. So he had there about 15 antennas on the roof of the building, and I was going just passing him on the right side. Okay, spectral scan. Well, for new technology. For AC technology, it is really important that you know your surrounding area, that you know about the space that you want to use for a link. And when you look at this graph, practically you can tell for sure there is no space to put 80 megahertz wide connection. So there is no space for this. So, and it is a real problem if you want to put a really high-speed link to outside, and you don't have 80 megahertz space, you will be not able to. Well, that's true. So you have to go not for a 80 megahertz channel. You not even will be able to use 40 megahertz channel. So in this case, actually, I was stopped at 20 megahertz wide channel to put the link. But you will see that the power throughput it's quite acceptable. So, and I did compare historical data. So I just did the test in November and last year. So I can compare the test with a new installation. So as you can see, there were like this is a day graph. So you can see each day, which I did compare for a week. And I was getting some data, and this was throughput of the old link. It was something about 48, 50 megabits per second. So the old technology that I did use, it did serve quite well. So because of the number of clients that we have, it was about 50 subscribers into that network, and they use roughly about 50 megabit of traffic. So it's a common value, I think, all over the world. So it's for us, it's usable. But what's the problem? The problem is that they want the customer wants more. So they not even customer, but the concurrence is pushing us to give them more. So that's the problem. So the link is starting to be the link that is right now there, or it was there. It started to be not efficient enough to get throughput to the clients. And I was comparing latency as well. As you know, if you use standard technology without NV2, without time division multiplex, you will have higher latency, because if the link goes onto the edge, so it goes to more than 50 megabits per second, you will start to have latency up to 200 milliseconds per second, and it is quite a high for example, player or somebody who is addicted to have low latency stuff or applications. So I did those tests on NV2 technology, so on time division multiplex. And with this setting, I got a little bit lower throughput. I have to say it was a little bit lower, but I got much better latency for a client. And that's what counts for them in that moment. So the latency for NV2 links, it was about from 1 to 8 milliseconds, and even in the high load, it is acting quite well. So you can really compare that it is much better than 200 milliseconds for old technology. So, and right now this is some test for the point to multipoint is the second link. The first tests were for point-to-point links, and this is for the second part of the test, and it is point-to-multipoint. Actually, well, this is at my home, where I do have connected few neighbors around, and I did have their Ubiquiti device, well, whatever. It was history stuff, I can call it. And you can see the roughly throughput of the old links that were there. I got about from the test. You can see there is about 80 megabits per second. But what's the catch? The catch is it is a UDP. I don't know if you did if I did mention before, but all tests I did, all tests that I am doing, I usually do on TCP protocol, because that's something that you need to know. The TCP information is more important for you than a UDP throughput, which is practically just information for you, not something that you will be using for a real. There's not lots of triple play providers. They will use lots of UDP bandwidth through your links. So if you look at it, and see that there is a 80 megabit per second UDP, so it will be about 40, and on the left side you can see for real it is a TCP says for 38 megabit per second. So that was the point-to-point link, the old one. It's not. It's fine for a standard customer, but we want more, so we will get it. So I just decided to put everything on site right now from that moment and switch it for AC. So I got replaced all the routers. In my case, I'm in Wi-Fi quite a long time, and I know that a pigtail is really something that you need to care of. It's not a piece of hardware. You can just replace the cards. You can leave the old pigtails there as well, but it will cost you lots of problems. And replace something for a €2 a piece, it doesn't make sense. If you are replacing devices for a few hundred, just replace all small parts that you need to. Because on some sites it is hard to get, like roof of the townhouses or something like this. And if you don't replace €2 part for a new one, you will get more troubles later. So I replaced all devices for a router boards 900 LNG 5 HP ACD, and I did replace the old Ubiquiti equipment for RBs 60s ACs as well, and for a access point I did use Metal 5. There is one catch, a little bit. Well, it's not a big problem, but it is in this moment that the Metal 5 has only a L3 license. So if you buy Metal 5, you have to, if you want to use it as an access point, you have to upgrade license. So I did upgrade it for a L4, so that it's enough for access points. And I just left the old antennas, the point links, only upgraded some parts for it that I needed. And from this point of view, my upgrade is really cost effective because it didn't cost me replacing antennas, didn't cost me not really much effort to do that. I just only bought a new router boards. It's okay, the router board is about €70 or something like this. So my investment into the replacing was quite low. And this is the picture of the device. And I did replace one part from a Euros antenna because I'm using Euros antennas for a point-to-point links. I just replaced the inside because there was a older type of it, and well, it's just few euro to replace it for a new one. So this is how it looks on the side. I know it's not really nice, but it is the real stuff. When you install something on the roof, well, it will be not nice and shiny. It will be like just old antenna, whatever. But inside is new. That's the important thing. Inside of the antenna, the router, that's what counts. And the most important thing, what you will find out when you install directional antennas, you have to have it in level, because it is dual polarization and use 811N technology, and it's using for modulation. It's using a QAM modulation. You have to have it in level, both sides. What did happen when we installed this link? The guys, I was installing on one side, and my technician or friend was installing on another side. And when we finished, we found out that, well, we didn't have really good experience from that because the throughput was slow, really low. Then I did found out that I didn't get higher modulation on the link. And there was high signal. I got about 50 something dBs. I got quality of the signal, but maximum to 60-70%. And so we found out that we had the pole or the mass of the antenna was not leveled. So we got it up to 10 degree, which was bent on the side. And this was the problem that we practically, after correcting, you can see on the right side, you can see the outcome of it. So we got practically a nice link which was running at 86% efficiency. It was not 100% because of the distance, and from this point, the antenna for this distance is quite small. Even if we use bigger antennas, we can get better throughput and better performance. But well, it's about cost, so we use the old ones. So, and because it was measured in real traffic, in real appliance, I did the test in 2 steps. First step was at till noon, so till 1 o'clock, and then the second test was done after 2 o'clock up to 9 o'clock at evening. As you know, the demographic data of the area is not equal, so you will not get same performance and information from the companies that they are working through the day, and then it will switch to home users when they work practically from 3 o'clock or something like this up to 9 o'clock at evening. So, and it is the highest throughput needed for your links. Good. So, and this is the performance of the point-to-point link. First screen or first graph is the old one. It is from November 2014, and it is practically the same area, but because of the diode, it is average. So sorry for that. You don't see the peaks, but it is an average value because of the diode is only carrying it's doing an average because of the amount of the data stored. But you can compare the same link, I mean the same area, the same connection in November and in January 2015. And as you can see, this is like real data from the clients. It's not tested. It's not pushed some bandwidth or something on it. This is the real stuff what you need to know. And as you can see, right now I got practically higher peak, higher demand from the clients. And in November it was 28 megabit per second, the peak of the value, and in January it was about 40 megabits per second. It's quite a different stuff. It's quite a different. It is about 1/3 higher than before. And the same at the evening. At the evening, I had practically the home users. They were in November. They were using about 30 megabits of throughput. The problem is that link that was before there had even maximum 50 megabits per second the throughput, so it was limited by the link as well. And right now, because there is lots of free space because of the AC, we got to the client up to 70 megabits per second. So okay, so this is like data what we collected from the users, and as you can see, it is about 40% rise demand from December to January. So in few months, the demand of the technology really rise up. The latency as well. The need or the question of the clients is to have a really tight and nice latency for the connections, to have they can play games, they can do stuff, they can have good Skype connections or whatever. So that's the reason why I'm using NV2. And as you can see, this is like real data from the link, and latency even at the high load will stay practically in values that they are usable. In a link that was before, it was about 200 milliseconds and more when it in high latency when it arose. Okay, so and then I did tested the link through the bandwidth test. So as you can see, this is the maximum what I got for this 9 kilometer long point-to-point link on 20 megahertz. So it is because of the interference, I was able only run 20 megahertz wide band, not more, but I got increase from 70 megabit per second for the old link up to 147 TCP connection. And in this, when it was tested, it was the real user traffic was there as well. So this is like just added another bandwidth test on it. So you can see it going a little bit up and down. That's the noise. That's because the user traffic. The router is right now processing something about 12,000 packets per second. It's quite okay for this 20 megahertz test. I'm just really satisfied with that. And then I was thinking, well, usually what's happened? Usually happened that after some period of time, the link will just go down because of the higher noise from the surrounding areas. So I did test. I done the same test in January when I put the link up, and a few days before, so we can compare how the link is stable during the time. I know it needs to be tested maybe a little bit more, maybe half a year. After half a year, we will see better difference of the stability. But well, I just got the devices in January, so. But as you can see, the performance stays. The performance of the link is still the same. Does not change during the time, at least in this 2 months period. Good. So that was about point-to-point link. I know it was a little bit, well, the performance, maybe you were expected that I am getting 300 megabit per second through the link. Well, it's not the case. It will never be because you will not find 80 megahertz wide channel outside. But what you can do for it is the best what we can do for the point-point links outside usually. In much better it will be in close point-to-multipoint links, because these point-to-multipoint links are in close distance, usually a few hundred meters. In my case, it was 300 meters area of access point and client installation. So you could, this is like the old test done again on the old devices, so we can compare it. So there is a 63 megabit throughput through the old configuration. And then I just decided to first assemble everything on the desk before installation. And even I had triple chain device. Well, I didn't have triple chain antenna, but for the test, well, I used everything what I got, so whatever. Later on, or right now, you can see that there are some triple chain antennas already on the market. And I just got it up on the roof. And this is the performance test of it. So you can see it's a TCP. Well, I don't do UDP test. Well, there is one UDP test just to show off. But the real data, what I did get. This is for, first thing I did install my client. So this is the test for our one client. And you can see the maximum throughput of this connection was 230 megabit per second TCP connection. It's quite a difference if you compare it with the 40 megabit of the older devices. And this is the main player, I think, in this moment. And latency, on the same side, you can see it on the left side. It is closed link, so the latency is quite stable. In when I was transmitting this 230 megabit per second, I got 3 milliseconds of the latency. So well, it's excellent. It's just perfect for a point-to-multipoint installation. Then I decided that I can do a UDP test as well. So why not? So you can see the throughput of it. So you can see that you really will be able to send 430 megabit UDP data through the link. For sure, it was a cloud core router to the cloud core router test. But in close, when we use it for real data, it will be really close to this amount of traffic that you will be able to send through the link. The main plus, what is into this close link, is that I am able to use 80 megahertz wide channel without problem, because it is really close. I don't have so much interference. I can even go down with the power output of the devices. Actually, in this case, I did use like 12 dB, so I didn't use full just 30 or something or 27 dB. What is setting of the device? I did use really 12 because it's really close area. I don't have to overload the area. And then I just connected 2 clients into it. So the second client, as you can see, I just put this screen so you can see the RX power level, and you can see practically modulations that they are up on both clients. So you can see modulation for one and second client. They are not equal because, well, some difference of area, some little bit different placing of the antenna. Well, it happened. So, and then I did the test for both clients on the same time. So I put it third CCR on his side to confirm that yes, I will be able to confirm the same procedure link to the same environment. And when I tested it, I got about 167 megabit per client. I did it both ways. So from one client I did upload, and from another client I did download at the same time. And this is like first time that you can see something like this on a MikroTik devices. 167 megabit full duplex from 2 different sources, but it is the same amount of data coming from one to another side. And the router is handling 32,000 packets per second. So really the device is able to handle high load traffic because the CPU is powerful enough. So I think this is really convincing that the link is quite fine. I have just last few words. For the point-to-point link, I can see that the performance is practically 3 times higher than the link that was there before. The latency stays in values that are acceptable for the high load. Only one problem that I did found, that is you will be not able to get 80 megahertz wide channel outside. But you don't have to worry anyway, because there is a regulation which tells us send only 20 megahertz wide channel outside anyway. So we should use not more than 20 megahertz wide channel. And I did find out that even in this high noise, the link, even from some problems from time to time, the latency will go a little bit up and down. It will not fail like the older technology. With older technology in high noise, it will even happen that it will disconnect and it reconnects again. We speak about it yesterday with a friend of mine that even he's running some older links and he has problem with the reconnection all the time. So he changed it to NV2 and it got much better. It will just not reconnect. It will stay connected even if there is some latency a little bit higher, but it will stay. And for the point-to-multipoint link, the performance is just, well, excellent. For close area, small things, the difference, well, 10 times more from if you compare it from before. And this is the first link what I did saw with 130 something megabit in full duplex, which is available on the market in this range of the cost range. Well, so that's everything, and I hope you did enjoy it, and I hope we meet somewhere else or later. Okay, thank you very much.